It's given. What you'd expect. Hello everyone, January 27th. 2 hot questions in a row. Let's take this one. Data stream as disjoint intervals. Oh my god. Intervals again? I freaking hate intervals. Given data stream put with non-negative integers. Summarize the numbers seen so far as a list of disjoint intervals. Implement summary ranges. Initialize the object with an empty stream. Void add num adds the integer value to the stream. Int. It's a list of list. Returns a summary of the integers in the stream currently as a list of disjoint intervals. The answer should be sorted by start. Okay, although I hate it, but this is actually quite useful. This is actually very useful. All right, so add 1, get return 1 to 1. Add 3, get return 1 1 and 3 3. Add 7 1 1 3 3 7 7. Add 2, get 1 to 3 7 to 7. Add 6 6 3 1 3 6 7 1 3. Oh, and let's have a follow-up. A hot question has a follow-up. What is that? Like super hard? What if there are lots of merges and the number of disjoint intervals is small compared to the size of the data stream? Whatever. Think. So we have a stream. So we keep number coming in and you need to put them into, and you don't know the value. Well, we know values is 0 to 10 to the 4th. Then what? First value come in. Okay. And then the second value come in. What if we already have an interval? If we have an interval, we just want to maintain it. Then the new number come in, we can always binary search to know where to kind of put it. Binary search by the start. And then if it's only a single value, so you can try to see compared to the previous one. If it's equal, then you ignore it. If it's within the first, if it's within the first, then you ignore it. If it's within the first, you ignore it. If it's 1 smaller than the start of the second, you change the second. If it's different, right? If it's too small than a second, okay, then you have to add it by itself. It will be a new one, right, by itself. So, and also this case, if it's larger, 1 larger than the previous, and the previous is too small than the second, and then you have to merge the 2. Ooh, merge the 2. Damn, we'll have to do this. We'll have to delete. Let's try. Maybe, I mean, it's a difficult question, right? But I do remember seeing the passing rate is 50%. 50. So maybe this naive solution will work. Who knows? Maybe it will. Maybe it truly will. Okay? All right, so what do you say? So we're gonna say self.range equals this. That's it, that's all we need. That's all we need. But we need bisect right, okay? So we add a value, right? We are going to say if not self.range, then we set self.range.append value, else index equals to bisect right. I'm going to search self.range and value key equals lambda tuple 0. Okay, so now we get the index. Now we have to see if it's a 0, Okay, if index is equal to 0, that means it's at the front. Then we have two conditions. We say if self.range 0, 0, because if it's the same, it's the same, it's going to be at the back, so it's going to be smaller, right? If when I say this is equal to value plus 1, then self.range 0, 0 is going to equal to value. Else, that means we have to add 1. So how do you insert? I've never do insert. Let's say a equals 1, 2, a dot insert index 1, insert a 10. Okay, so that in the range, the insert at position 0, we're gonna insert insert what? Insert value and a value. In fact, we say bisect right a, doesn't matter. Yeah, it'll give us 0. So actually I don't need to check this one. Okay. Let's say if not self.range or self.range 0, 0 is larger than value plus 1, then we're just going to insert. Okay. And then we're going to say else. Do this. Okay. Else. Now we're going to first compare, right? When I say if self.range index minus 1, 0 smaller equal to value smaller equal to self.range index minus 1, 1, then return. We don't have to change anything. Else, if right, it's inside this, if it's equal to the next, well, that's not possible because equal to next will be going to the behind, so it definitely will be smaller to the next. Then the next condition is it's larger than this, right? If it's larger than this, we have two scenarios. We can say if self, right, dot range index minus 1, 1 plus 1 is equal to value, so value is that, and holy crap, and value is smaller than self. What if it's at the end? Then we don't have anything. Damn it. Alright, this has to be else. We have to consider another situation if index is equal to len self.range. Now we're talking about it's at the back, right? Then we need to do this check. We always have to do this check. Which actually we just need to do this if it's larger than, right? If it's larger than, we should say equal to this plus 1, then self.range index minus 1, 1 is equal to value, right? If value is larger than self.range index minus 1, 1 plus 1, it's larger than this, then self.range.append value and value. That's it. The last one we don't have to change. Here is the same thing, right? The same thing. So the first condition, let's compare this. If it's equal to this one plus 1 but smaller than self.range index 0 minus 1. Okay, so that means we are larger, we're equal to the previous plus 1 but we are smaller than the next one, -1. So we cannot merge the two. So if that's the case, then we just need to do self.range index -1, 1 is equal to value. Done. Elif, same thing, but now this is going to be equal to. Okay, so now the value is going to be the connecting point between the two. So we need to delete. How do we delete? A.pop index 1. So 2 will be popped. Yes, so we need to pop. Oh, so what we need to do is we can pop. Let's pop index, okay? So we can say low high will equal to self.range.pop. Okay, we're gonna pop index. Now once we pop index is the latter one, so we need to replace self.range index. Holy crap, that's no longer index -1, because if we pop it, right? Hold on. If for 0, 1, 2, 3, we pop it. That's still index -1. Index -1 does not change. Huh. So this one need to equal to high. That's when we connect the two. Elif value. So still the same here, but this is smaller, and this is equal to. Okay, then self.range index 0 shall equal to value. Right? Elif this and this is smaller. Right, so value is larger than the 1 plus 1, smaller than this -1. So now we need to do self.range insert. We insert that index, value and value. That's it. The only case we did not consider is this, and this one we don't have to consider anyway. So yeah, that's about it. And then we just return self.range. All right, let's see. I mean, okay, just give a shot. Yeah, we pass. So the most naive solution does work. A difficult question, medium question disguise is difficult. $352. Just analyze the hell out of merging conditions. O1 for get intervals, ON for add num. So what about this? Lots of merges and the number of disjoint is small. Lots of merges. I guess if it's lots of merges, I don't know. I mean, I'll still do the same way. I don't know what it's trying to get at, but let's read. Save all values in order set. Sorted interval, huh? They use sorted set. Sorted list, yeah. So the insert will be all log n. And that will be maintain all the intervals in order map. A tree map. Every entry represents an interval. Key and value. That, oh, I did not remember that. Key and value. Oh, that's actually we just have to keep it sorted every single time. Sorted dict can be used to do this. Yes, then when you delete, I think you can do O1 and delete, but you still O log n need to insert will be O log n. You just need to analyze it. O log n add. And this you just need to do O(n) to get interval. Now your self.add. Oh, it's a sorted list. Sorted list. Using sorted list. I am using my trusted I don't want to use sorted list. That's an external library. You cannot use sorted list in an interview. Otherwise, a lot of problems will be easy to deal with. So yeah, I think I'll stick with this. Or binary search at the beginning. And it's more expensive because of the insert. But hey, it allowed me to pass. So that's that. Okay. Now the real challenge. We have been delaying on this for so long. I mean, we have a solution. We have an idea. Oh my god, I kind of forgot. Holy crap. Dude. Okay, we need to first compute the current. Okay, so based on we need to know their power using R. So we need to know their power. So if R 2 times R plus 1, that's the total range. And we can simply sliding window. Okay, we can sliding window it. Okay, let's I want to build it first. So sliding window, we need to know power. Okay, so for the first one is this plus R, right? So that will be the starting point. So we have a left and a right. So from the low and a high. And this low and high, actually we should do low and high first. So low is going to be 0, high is going to be R, right? Because R is 1, 0, 1, this is a high. And then the first one is going to be sum stations low to high plus 1. Right, so that's the start. And then, this is the previous value. And then we say while R is smaller than len stations. No, not R. High is smaller than stations. then we can say high plus equal 1. Actually, I want to do high plus equal 1 here, okay? Because I always move forward. So high plus equal 1. And then we can say current equals powers hold on, we can say powers dot append powers -1 plus stations high, right? Then we say if high minus low plus 1, right? So 0, 1, 2. So if we handle this, right, 0, 1. So now we have here. So 2, so it'll be 3. If this is larger than, okay, now larger than 2 times r plus 1, then powers -1 minus equal to stations low, and then low plus equal 1. Otherwise, we don't change. And then high plus equal 1. And then we'll keep going until we're done. And let's see what the powers is. Let's see if it makes sense. Yeah, this time probably have to go step by step. Just make sure every step is correct. And I'll just make debugging easier. That's basically what it is. This is basically an edge case. 4. Okay. Stations are okay. Max power stations are okay. Oh shoot, we're missing one. We're missing one. We added, so this is 9. We got this. How about this? So this does not keep growing, and this needs to reduce. This needs to reduce. So I think that's not true. That should be while low and smaller than high, right? And then hold on. That's what it gets. No. Because at the end, low and high shall be r apart. So while high minus low is larger or equal to r. Okay, then we do this, and we also want n equals land stations. So blah 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 equals high plus 1, the minimum of high plus 1 and n minus 1. Oh shoot, damn. That's holy crap. How do I handle the last? Because it's or if this or high is equal to n minus 1, then we need to reduce. And so if high is smaller than n minus 1, then high plus equal 1. Alright, that's, we got too much, because this is 3, 7, 11, 9, 5. We got one more. Y. So let's just do is larger than R. Okay, larger than R. Why? So because this minus this, what we need is this minus if high minus low is equal to R. We will add hold a second. Hold a second. Powers that append this plus high. It just so happens it's 1. That's why it's kind of, yeah. If it's not, no, that's actually not right. It's if high is too big, then it's not gonna work. Should be. Ooh, high. Hold on. Okay, so they are here. Power plus, so high plus equal high is here. And then we add this. This is too much, so we minus this. Now we have this. Okay, that's 9. And then next, high, I shall make it here. And then here, high minus larger, But I don't add, and I say it's equal to n. So we will remove this, so it will become, this will be 5. And then this one doesn't do, low plus equal 1. Right, so here, low will be here. Right, low plus equal 1. And then coming back up. Now, 0, 1, 2, 3. Low is 3. High is 5. Right, 5 minus 3 is 2. Shall be low. The smallest low can go shall be n minus 1 minus r. Right? n minus 1 minus r. So I'll change this. If low, while low is smaller or equal to n minus 1 minus r. Right? And then we say if high is smaller than n, then we always do this. This is n. And now if smaller than n. What? Ah. 3, 7, 11. How come we just directly go to 0? Seven, 11 is here. n minus 1. R is 1 minus 1. So I say low can be 5. But right now, low is at 11. Right? At 11, low is here. So next one, low is here. Where's 9? It's interesting. Hold on. Let's see low and high. Okay, 0 to 0, 3, 0 to 0 2. coming in 0, 0, 3, and the next one is 1, 0, 0, 1, 2, 3, 0, 3. Next one 1, 4. One, 4. Yeah, pen 4. 4 minus 1 is 3. It's larger than that. So minus 2. Oh, you did not? Yeah, you did. Then where's 1? What the hell? I have 9. Oh, because I no longer append. Oh, we still need to append, man. Powers need to append plus this if high is more than n, else 0. Or we can just times int high smaller than n. That's actually easier. Oh, actually we cannot do it this way. Yeah, I see it. Okay, so we have to do this way, otherwise we'll be out of range. So plus this. Okay. Low 0, 1, 2, 2, 5. Okay. Then low plus 1. So at this point, I will minus this, which means this is already done, so it has to be smaller than, so it cannot be equal to. Yep, that's more like it. Okay. Yeah, it take a while just to get this one done. Okay. Now what? Now what we're gonna do is binary search. We need to wait. Did we sort this? Yes, we need to sort this. If I remember powers, we need to sort this, right? And then, because we only need to handle the smallest, because the bigger ones we don't really care, right? So we need to get the possible value, right? Because this is 2, so everyone and most one can get 2, and the max value, so we can have a low and high here, right? We can say low and high. Low is going to be powers 0. Oh, I know. No. What is this? Low and high is the final power, right? Final power. Yeah, that's the low. High is going to be powers minus 1 plus k plus 1. So it'll be higher than that. So while low smaller than high, mid equal to low plus high divided by 2, right? Then you can say if it's impossible, if it cannot reach, then we go to the left. So what is impossible? We say if mid minus powers 0, which means the total if it's larger than k, that means it's impossible. We cannot bring it to that level. And then we say high equals mid. Okay. If the total needed, okay, the total needed is, I mean, we can do a prefix sum on this. Okay, we can do a prefix sum, and then we can binary search again to find where the median point will be, and then we find a total needed power, and then the total power that can be added, right? Can be added in total because we have 2, right? We have a range is 1, so at most is going to be 3, right? At most we can solve 3, and then we do another 3, right? So 2 times r plus 1 is the total range each power station can supply, and have 2, so it'll be 6. At most we can add 6 in total. So if the total is beyond that, then that's not possible. So what we need to do is we need to get a prefix sum. So from iter tools, we import accumulate, right? So we can say presum equals list accumulate powers. Okay. Now, we also need a binary search from bisect import bisect right. Doesn't really matter which one you use. So if it's larger than 1 or else, you can say index equals bisect right powers, and what is my current mid, right? So then, because it's equal, that's fine. I mean, if it's equal, if this is equal, we shall go for the previous one. So maybe bisect left will be a better option. So yeah, let's go bisect left. So if it's equal, then I don't have to add it, right? We just want to find how many of them need help. So bisect left. So if it's even, we go for the one in front, which is just myself, right? So we can always go. Yeah, that's the mid, right? That's the mid value, and we're saying that's gonna be index. Oof, it's gonna be index. If it's the same, then we should do one previous. If else, it's gonna be small, large. That's gonna fall here. It's the same, just index minus 1, index minus 1. And I'm pretty sure index should not be 0. Nah, it should not be 0. So index minus 1. So we can say total shall equal to presum index, right? This to the minus 1. That's the total, right? That's the total. And then we say if the total that's needed is larger than what we can provide, is k times 2 times r plus 1. This is the maximum we can provide. If it's larger than, that means it's not possible. Then we say high equals mid. Okay? Else, if it's possible, right? If it's the first one is possible, total is possible, then we need to do one more is see if it's possible. Now this is the real thing. Yeah, we don't know. We will deal with this later. So if this, else we have another if. Okay, we have another if, and then we have an else. And this else is everything is possible. Then we just say low equals mid plus 1. Okay, so we'll blah blah blah, and eventually we'll return, I think return low minus 1. That's what I think we'll return, because it's possible, so we move forward, and then anytime it fails, this will move back. So whatever came out is something that's not possible. So we need to do this minus 1. Okay, so now how do we tell the next? The next is a rough check all pass, right? A rough check all pass. So what we need is to get, we want to see if it's possible. So we want to do the optimal. Okay, So we need to know the original indices. We need to know their index. We need to know the powers index. Okay, so those are the ones that needs help. So if we know their indices, right? If we know their indices, and then we pull those indices out, because those are the ones that requires help. We pull the indices out, or we need to sort in this index. It's unfortunate, we have to sort the index, and then we can say, okay, we want to put all the power starting from this index, right? So the leftmost, we have to fill all of it, and then we can say, okay, the left needs however many, and we count that, and then we say what is the rank, how far it can lead. Okay, so it can farthest it can lead to this. Okay, and then from there we can check, right? We can check if this is reach the next one. If it does reach the next one can already have whatever it has. If it does not, then the next one have to restart. So we for one, we have to, holy moly, can we put the indices as we're doing it? I think yes we can. So sum of this and 0, okay, and there should be append power 0, and powers -1, 1 plus 1. All right, now we have to, yeah, we can sort. Oh, what if they're the same? Does not matter. So now this accumulate, yeah, p for p underscore in powers. Okay, so this one, yeah, this one has to be just the power, and then low will be 0, 0, 0 plus and while I had this, just do this, powers 0, 0, and then bisect, we have to say key equals lambda tuple 0, and then blah blah blah. That's fine, but I do want to, before we do anything else, check one more time. Powers, look at this, minus powers this 0 minus this. Oh, gotta be kidding me. Cannot do tuple, fortunately. Okay, 0, 1, 2, 3, 4. Yes, that's fine. And now we can sort. Yep. You want to check this? Yep, that's fine. Okay, so this should be fine. Now we need to do, we already have index, right? So index -1. So we can say indices shall equal to sorted. Okay, sorted for I in range to index. So we don't want to include index, and then this is just going to be powers I1. We only need indices, and then we sorted. Okay, then we just want to know if it's possible, right, with the mid power. Oh, how do we do this? Holy crap. okay, prefill. Okay, we have a prefill is equal to 0 at the beginning, and then we need to go for I in indices. Okay, so for the first one we have a prefill, so we need to know how many we need to fill, right? We say how many we need to fill. To fill, now we just see, you know, how much we need to fill, how much we need to fill, which is just mid need to allowed. We need to keep mid, so prefill allowed is going to be mid. Okay, now we say allowed or minus equal to the total we need to fill is what we have at this position, right? What we have at this position is, what do we have at this position? Now we have its indices, which means we can get it by calling powers. But powers, we already sorted it. We don't even know. Yo, man. That is bonkers. Alright, so we need to sort. We need to sort powers. We need to have all of them, unfortunately. So we need to sort it. So then we don't need this. We can just say to index. Okay, we're going to sort this. Key equals lambda. Tuple, we're going to sort by this. Then it's indices. Index power. Sorted. Index power. I call index power. Okay. So now we have I and P in index power. Actually, we probably can do it here. I don't need to. Do we need to access? Just in case. So, right, allowed. And allowed is not mid, Lord. Allowed is the that's the K, right? That's the K. Allowed is K. K is the total power station allowed, right? So allowed into minus equal to, for this station, for the current station, how many do we need to use? So we have the original power, we have P, right? Minus prefill, okay? Minus prefill. So after a minus prefill, that is the amount, okay? That is the amount that we need to add. And now we say allowed minus this. Now we can say needed equals P minus prefill. And we say if needed, right, is smaller or equal to allowed, or needed is larger than allowed, then we can break, which means it's not possible. Otherwise, allowed minus equal needed. Okay. Now, these needed might spill over to the next one, so we need to know the next power, right? What is the next one? Ooh, that is. So the next one, holy crap! Oh my god, when we need a. All right, so we need a J. We need to enumerate this thing because I need to know the next one. Okay. So the next one, right? The next one shall be, we can say if I plus 1 is smaller than len, index power. So we have the next one. Then we need to see the next one, right? And if these two are within the range, now what it can be is we have multiple. Oh my god. Oh my god. So, okay, hold on. K equals 0. No. For K in range, for J in range, I have J already. For K in range, oh my god, we need to know each one of them. Powers. Interesting. We can deduct from powers directly. Yeah, we can deduct from powers directly. And I think it's allowed when we enumerate it to that. Hold on. This is actually a good question. If we say A equals 1, 2, 3, 4, okay? We can say for I, P, Q, being enumerate A, we say A, I plus 1, if I is smaller than 2, right? Let's say I plus 1 smaller than 2. So I plus 1, 0, I change it to 100. Okay. Then we'll print P and Q. Yeah, you see? We can modify it. So we don't need preview because we can change it, right? Because we say for K in range I plus 1 all the way to index power, right? All the way to the end. What we need, right? What do we need? We need to know the next index. So the next index is going to be index power K. 0, that, no, 1, that is in the next one. And here is wrong, this is P and J. Because I did not swap them. So this is the next index, right? What we need to know is whether the distance between the two is smaller or equal to the range, right? So we say this minus J, which is the current, right? This is the current. J is the current one that I'm adding power to. So the next one, it's index minus J plus 1. If this is smaller or equal to 2 times R plus 1, that's the total range, right? If it's smaller or equal to, now of course we don't need plus 1. If that's the case, then index power K0 can minus and equal to our required can be reduced because we added needed amount to it. So we can minus equal to needed, right? We can minus equal to needed. We can minus equal to needed. The needed, wait, hold a second. This is not true, all right? It's not P, it's needed is mid minus P. That's the needed. Come on, mid is what we want to reach. P is the current power. So this needed, that's the needed. If the needed is larger than, no go. If it's smaller than, then we can fill it, right? Then we can fill it. And then allowed, we will reduce the needed, right? Well, we can keep doing the needed for the further on. If it's within the range, then its power can no, not minus, it's plus. We'll add that much, okay? We'll add that much. Right? We'll add that much, which means we can say if mid is smaller equal to p, right? Then we can just continue, which means this one we don't need to do it anymore. We can continue. Otherwise, we'll do this, and then we just keep adding, right? And then we go to the next one, and then we can, if it's still within, we keep adding until a point where this is larger than. So it's outside the range. So if it's outside the range, else we can break. We come out. Okay. Now we come out, right? So we have pre-filled everybody. Now we go on to the next one, right? We go on to the next one. And then when we go on to the next one, we check if we need to fill. If we don't need to fill, go on to the next one, right? We go on to the next one until we find something we need to fill. If we find something we need to fill, we always set the edge to that thing, okay? And then we add whatever we need to add to it. And then we see if it's, possible. And then we extend, right? We extend into the future, right? So which means, actually I want to change its value as well. Needed is this, right? Well, we can assign to needed. I can assign it to mid. It's not necessary, right? Okay, so blah, blah, blah. Break, right? So break. We can say else. If else, that means we have filled every single one. The needed larger than allowed never occurred, okay? It never occurred. Then that means it's possible, which here is low equals mid plus 1. And we'll continue. Otherwise, if we break out, that means it's not possible. High equals mid. Yeah, it's slightly different than what I had expected. Okay, I think we constructed it. We can just run it. Oh, we haven't changed this yet. No, we changed it. Oh, we have other issues. Oh, of course. Of course. Oh, we passed the first one, but we failed the second one. Very interesting. Result, I returned 3. R is 0, which means everyone can only handle for itself. Huh, that's interesting. Why would you do 3? Because low come out, low and high is powers low and high. Let's see what this powers is this. Yes, low and high is 4 and 8. Ooh, 4 and 8. Okay. Low, mid, high. Let's just take a look. 4, 6, 8, 4, 5, 6, 4, 4, 5. 4, 4, 5, 4, 4, 5, 4, 4, 5. So are you saying we need to this one minus 1? No, then we just keep dropping. Yeah, that's not right. So we got to 4, right? We got to the level. We got to this level, but oh my god. Because we get 4, 4, 5, and 4, 4, 5 probably high equal to mid, because 4. Because I say 4 is not possible. Really? In this case, 4 is not possible. Wait, how? How is 4 not possible? Mid 4, right? 4 minus power 0, 0 is larger. That's not true. Let's move this one somewhere else. Let's move it here, just to ensure we are. Ooh, that's ugly. Oh, pre-sum. Oh, it's mid. Yo, mid times index minus. I don't know what you're thinking, man. Why I just kept forgetting to do mid times, and how is the first one pass still? Anyway, all right, we're gonna just try it once. If it fails, we're gonna call it a day. Yeah, let's just do it. It's okay. If it fails, then it fails. All right. Come on. Of course, I hope it does not fail. And the worst will be timeout. Okay, so we have a wrong answer. So that means we can analyze it and then try to see what we got wrong, which I have no intention to do today. What's the answer? Expected 9, output 8. Something with binary search. That's my guess. Because if we return 8, that means actually it's 9, right? Which means 9 is possible. Oh, there's some binary search stuff. Yeah, but if you think about it, they keep going low, go up, low, go up, low, go up. Yeah, if every time is possible, go up, possible, go up, possible, and go up, we never really check the high, right? So how do we? It's low, mid, plus 1. So when it comes out, we need to check if it's possible, right? So we do low smaller equal to high. Okay. Then if it's smaller equal to high, then we do it one more time. And if it's not possible, then we can do high equals mid minus 1. Okay? High equals mid minus 1. It's not possible. And then we come out. But we don't know. It's just this check takes too long. Right? Because I already done the last check. How about this? I do low smaller equal to high, right? And then everything else I stay the same. Then when high equals to mid, if the last one, so the last one will be low equal to high, right? So when low equal to high and I come out, it's still low equal to high. That means, because if it's possible, then low will go higher. Right? So what if we do this? Smaller equal to, right? And then blah, blah, blah at the end, we say if low is equal to high. But that will be the first time, right? If it's the first time low equal to high, then we shall do it again. Then how do you know it's the first time? Oh. So eventually low will be equal to high, and I want to do it one more time so I know. And then if it's impossible, mid will go low. If it's possible, low will go high, right? And then if it's possible, low will go high. So we shall return low minus 1. If it's impossible, then mid will minus 1. So, which means if we do this, minus 1, and high minus 1, then we return low. Ugh, it gets even worse. Answer is 9. How is this possible? I thought I did not do low equal to high. Wait, did we even have low equal to high? We have 8 and 9. We have 8 and 9. And then what? And then mid minus 1. How is that possible, mid minus 1? Hold up. This might be an infinite, yeah. Yeah? So keep it in 9. So I was hoping high will be minus 1. Right? Because it's basic. Wait, hold up. It's 8, 9. And then low plus equal 1. That becomes 9, 9. Right? 9, 9 if high minus 1. I don't understand. I thought this is right. Hold on. Low is 8, high is 7. That doesn't make any sense. That does not make any sense. Come on, man. That does not make any sense. So after first round, it'll be 213. And then there shall be 15. Right? Oh, I think this is a binary search issue. Start with 14, and then we do 13. Okay, now it's 7. What happened to 7? What is this 10? Wait, 1 is 7. We don't even come here? Oh, we break here. No, we break here. Oh, I see. So we need to print here, low and high. Alright, so 14 will be 7. Alright, this is 7, and then low will be A13. A13 will be 10. and then it'll be 8, 9, right? 8, 9, we do 8. 8, 9, we do 8. And then, oh, 8, 9, we do 8. And then, apparently it's not possible. 8 is not possible. 8 is not possible. That is an issue. 8 is not possible. But how do we get to... Hold up. Let's use our most trusted. This is our most trusted, right? 8. Yeah, 8 is possible. I don't know why 8 is not possible. Like, what the hell? And this should be a copy, so I shouldn't worry about it change the original value. And 9 and 10, right? 9 and then 9 and 9. And then we get out because we didn't know. So how come, right? That's all fine. How come when we do this -1, 8 becomes not possible? That is a very serious problem. That don't know what happened. Right? In this one, we have 8. And it come up with it's not possible. Well, one way to see is that's the powers. Okay. There's no change. Yeah, so if it's 8, okay, 8 minus, what's the power level? We can have 9. Cover 0. No, hold on, we have K is 14, we have 14, and everyone by itself. Okay, everyone by itself. So mid minus power 0, 0. Mid is 8, so this is 6. Alright, say larger than K, no. Index, mid is 8, so it'll be here. Alright. And then say, so index, it should be 2. Right? The index should be 2. Let's confirm. That's how you're not gonna do it here. Yeah, just one analysis. I don't even do index. That's weird. Okay. Okay. Jesus. Oh man. But do we still have the same problem? Yeah, we do still have the same problem, I think. Because it could be, yeah. So K, change the name. Q. I don't think we use Q. I definitely will be fine. Okay, this one pass. And yeah, because of this, it's guaranteed to pass. But because if it's the other way, actually, let's try the other way. If this is smaller, and this we don't -1, and don't minus 1. I think it's still gonna be wrong. It's right. It's right. It's just gonna go higher. Okay. Let's comment all the printout. We don't need this. Print this. No, not print this. We'll comment all these out. Okay. I think that's a little, just a little problem. Nothing to be worried. It's a small issue. All right. Let's try one more time. Yeah, I was modifying K. One more time. Come on. Come on. Come on. Come on. Come on. Shake it. Shake it. Shake it. Shake it. Ah, that takes so long. Wrong answer. All right, so we gotta stop here. Okay, we'll copy and paste this and we'll analyze it tomorrow. My answer is 147, but expected is 197, only 4. Okay, we'll do this tomorrow. I'll see you guys tomorrow. Adios.